Hey Dude, welcome back. Today we talk about problem number 55 jump game. You are given an integer array called nums. You are initially positioned at the array first index, and each element in the array represents your maximum length at that position. Return true if you can reach the last index or false otherwise. You remember that we solved this problem before, but we have a naive solution. Today we'll try to solve it with a better solution. So let's discuss how this problem works. If we have this array, we should return true. Why? Because we jump one step from index 0 to index 1, and after that we jump 3 steps and we go to the last index from index 1. So the key here, as you can know, is that if we are at index 0, we have two options. We can jump 1 steps or 2 steps because we have a value of number 2, because we can jump for each value. And in number 3, we have 3 options. We can jump 1 step, 2 steps, and 3 steps. And so on and so forth. And if we want to take a look at this element, at this array, it should return false because no matter what, we will end at index 0. So try to jump 3 steps directly, you'll be at 0. Try to jump 2 steps from here, you'll be at 1, and from 1 you'll be at 0. Try to jump 1 step, you will be at number 2, and from number 2 try to jump 2 steps, you'll be at 0. Try to jump 1 step, you'll be at 1, and from 1 you'll be at 0 again. So no matter how hard you try, you will end at this index and you will never reach the end. So how we can solve this problem? In our previous solution, we tried to do it exactly like that. So we were let me change the color so it will be something bright. We wanted to do it like that. So we want to go to each element and we try all the possible solutions. Like for example, we have only 2 jumps, let's try all of them. We have here 3 jumps, let's try all of them, and so on, so forth. But there is a better solution that we can do. We can continue doing that. We can just try to jump every possible solution, but we can just implement some sort of cache or some sort of memorization. For example, if we have like we assign all the numbers good and bad rating. So basically, bad means it cannot go to the end, and good means it could go to the end. So let's say that one is good, or this one also is good because we can reach the end from this one. So once two reaches this element, we don't have to check all the other elements because this one directly reach the end. And by doing caching, we'll improve our code, and we will not do recursion as we did before. We'll just make a loop, and once we reach a good number, or a number that is assigned as a good, we return it directly, and that's it. So let's try to see how it works in code because it's pretty simple in coding. So first we want to create our an object that we will call good, bad, or unknown, and we want to create a function, okay, and we call it. Let's make this one cut here, and let's make the code editor bigger. Yeah, it's way more better right now. And we create a function and we call it can jump position, and it will take 3 arguments: the position, and it will take nums, and also it will take the memo. Okay. Let's try to see how we will do it. So I would say, okay, if from this one I would call the can jump position from this function, and this one is basically its purpose to know whether the nums array can be reached by the end or not. So let's try to think it like that. First, I want to create a memo array. This will be our cache. It will be equals new array. It will be from nums.length. Okay, and I will fill it dot fill unknown index dot unknown because I don't know their the values. And there's something it's quite important to add. We want to make the last element of the time good because we can it's the end and we can reach the end from the end. Yeah, it's pretty obvious. So let's create a memo, and the memo here I would say the last element, which will be memo to be memo.length 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 minus 1, I guess. It will be equals to index dot good, and I will call the can jump here, and I will give it 3 arguments. The position was starting from the beginning, so starting from the 0, the first index. I only want to give it the nums array, and I want to give it the memo. Okay, let's try to fire everything here. So first I want to say if the memo of position doesn't equal index dot unknown, if the current position that we're trying to check doesn't equal unknown, we want to return if we want to do this. What this means basically here, it means we return a boolean with a true or false. I'm saying if the memo position equals index good, it will be whether true or false. So we return it and we don't have to make any loops with it. Also right now we need to do the looping. So first I want to know what is a furthest jump, so we will not make any overlapping in our array. So the further jump, and it will equal math.min and to be position plus nums of position and nums dot length minus 1. Here, what position plus position? So let's say that we are in this position. Let me give this one. We are in this position. I want to know what is the fastest place or the fastest jump that we can reach. So we can do that by first know our own index, and we do our index from position. So we know our position, and after that we start to add to it the value that we can have. So if the value doesn't exceed the end of the array, we take it. If it exceeded the end of the array, we just take nums.length minus 1, and yeah, that's it. I want to make a for loop here. I would say let next it will equals next position, or let's just call it next only because next position will be like quite annoying to write, and it will equals position plus 1. Next position next should be less than or equals the farthest jump. Okay, and the next will be minus plus plus. next plus plus, and I guess everything looks good here. I just do it like that, and let's right now do everything we want to do. So I'll say if the can jump, because it will be recurrent, we call the function again. If the can jump of next and nums, and I put the memo. If that was if we can jump from there, we will make memo of the position equals index dot good, and we will return true from this one. Otherwise, we make memo of the position equals index dot bad, and we return false. And basically that's it. But I guess we need to discuss. First, let me run. It didn't work. Why? I returned undefined. Why I did return undefined? I cannot return undefined. Why I will return undefined? Sorry, I have to return this function. Let me run again. Oh, there's something wrong I have done here. Let me check why. So the output was false and I expected it to be true. Why? Okay. Let me try to explain the code in details here. So first we have the index simulation. So the index object simulates the enum in JavaScript, representing the state good, bad, and unknown of each index in the nums array. This one's the purpose of it. After that, we have the recursive function, which is called canJump. This function checks if it's possible to jump to the end from a given position in the array. It uses memorizations to start and reuse results for each position, reducing redundant calculations. Also, if the current position is already evaluated good or bad, from here, good or bad, it returns the result immediately. Otherwise, it checks if there is any valid jump from the current positions to the further one within the range allowed by the value at num's position. If a valid path is found, the current position is marked as good. Otherwise, it is marked as bad after checking all positions. And we have in the main function here, we initialize the memo array within the status unknown for each index, except for the last index, which is marked as good. And it is then called can jump position, starting from the first position, which is index at 0, to determine if the end is reachable. So let me think about this one. So I guess this is the toughest thing to understand here. Here we call the function. I guess it's an enum value for we assign for each element. And for this one, we just making like some sort of base case because we are calling a recursive function. And when you have a recursive function, you want all the time to have a base case for yourself. So we will start by calculating the fastest jump because we don't want to make any overlaying for the array. And after that, we have we're looping for next position, and from each position, other position, we call the can jump again. And here we're trying to know if and the can jump basically it will be fired again, and we'll basically call the recursive function repeatedly until we reach the end. And if we can't reach the end from a specific index, it will be called as bad. If we can reach the end in the index, it will be called true, and it will be returned for the other recursive functions. Let me submit the code and see if we got limited exceeded or not later. And okay, it's yeah, it's not that bad. I'm beating only 10%. It's over, but it's really bad. So yeah, that's it for today's video. And in the next video, I'll try to find third solution. We have 4 solutions for this problem. The third solution, it will be exactly the same, but we'll start from the end instead of the beginning. After that, we could work with the better solution, which will be the greedy algorithms. So that's it for this video. And I hope you like my content. If you like my content, subscribe and hit the notification bell so never miss a video, and see you in future problems. Where I should stop. Stop.